All right, so today, class, we're going to be talking about homeostasis and feedback loops. And when you think about homeostasis, remember balance. Its purpose is to keep your body balanced. So think about a scale. The actual definition would be your body's ability to maintain a relatively constant internal environment. So remember, constant internal environment when you think about homeostasis. So when something isn't at dynamic equilibrium or this constant internal environment, then your body would undergo a feedback loop. And there's a couple steps in this feedback loop, and one would be to sense the change of the stimulus, two, signal body parts that can help respond to the stimulus, and three, have the cells, tissues, and organs respond. The response would either lessen or reverse the changes, and hopefully it will bring it back to homeostasis. And this entire process, like I mentioned, is a feedback loop. All right, so I just have another picture just to go over a feedback loop one more time. So, one is the stimulus produces the change in the variable. Two, the change is detected by the receptor, and that's the sensor. And then the information is sent to an afferent pathway to the control center. And then the information from the control center is sent along to an efferent pathway to the effector. And the effector is what um, feeds back to it's the response. It feeds back to the stimulus and hopefully will return the variable to homeostasis. So you see it being returned to homeostasis, but it started out as an imbalance. So there's two feedback loops. There's negative feedback loop, which are actions to reduce or stop the stimulus, and then the positive feedback loop, which enhances and adds to the stimulus and response. So you see in this little cartoon the positive feedback and the negative feedback. So the negative feedback, how to counteract this, and then the positive feedback would be like more. They're adding to the stimulus. So here's an example of a negative feedback loop. So you have the stimulus, which would be the body temperature exceeding 37 degrees Celsius, which is the homeostasis. So then you have the sensors, which would be the nerve cells in the skin and the brain. They sense the change. And then you have the control, which would be the temperature regulatory center in the brain. They control, and it communicates with the effector, which will submit the response to hopefully bring back to homeostasis. So your sweat glands throughout the body will start sweating, and then hopefully the response would be to bring back to homeostasis. So here's a positive feedback loop. The head of the baby pushes against the cervix. The nerve impulses from the cervix is transmitted to the brain, and then the brain stimulates the pituitary gland to secrete oxytocin, and then the oxytocin carried in bloodstream to the uterus. The oxytocin stimulates uterine contractions and pushes the baby towards the cervix. So the head of the baby pushes against the cervix again, so that adds the stimulus.